Hello all and welcome to my channel. Today another DIY project, but I think many will be interested in it. So for introduction, what you think, what you can get if you take one Arduino Nano board, one duck digital to analog converter. This is 12 bits MCP 4725 DAC module or DAC, one encoder and one display. When you complete all four, you get something like exactly this, and you could see it in my previous video. This is adjustable precision millivolt source. It goes from 1 millivolt to up to 200-300, so dependable of Arduino code. So stay with me. There are many important things to know about it, how to make it real precision millivolt source. So how it works, let me show you before I show you wall code and all tricks needed to be done in code to get precision. Okay, it needs a little time to start always. You see how it goes. So it's 20 millivolt, and let me show you 20 millivolts on instrument, 20 millivolts here. Let's go down 19, 18, 17. You see measurement on my desktop instrument, what, 14, and it going like offset 10. I could also be more precise with this, but it going 0, 0, 10. No more zeros or whatever. It's 10 millivolt. No 10 point something, it's 10 millivolts. So what you read on this instrument, it's 10 millivolts. So forget what is behind that, because you can't find so many instruments which have so huge resolution like this Zoe desktop multimeter, which is affordable but very good, and it took place on my desktop forever. I don't need anything better for everything I doing here. So if you think I am wrong, I will take another instrument of high resolution or precision. Let's see what it was showing. It's showing same like Zoe, so two instruments with same results. That is important to me. 1 millivolt, less than 1 millivolt, that is not important, really. Okay, enough about this. You've seen how it works, and you will see how to adjust code, what you have to do, and of course schematic, how to build it. So here is the code full, and it will be uploaded to my Google Drive, so you can download it as you see it. In this code, one line is important. It's this line. That is voltage reference line, which you take by measuring your Arduino. Take your Arduino, power it on. There we go. Take your instrument. So measure plus 5 volt. You see on this Arduino 4.65. what is with 3.3? 3.26 quite okay, but 5 volt is 4.65. In Arduino board, which is used in here, voltage was 4.72. Other than that, in this line, in this Arduino code, what you see on the screen, other than that, only important things are adjustments for different ranges of millivolt source. Like you can see here, I adjusted what it will show on display by these lines, and every line represent a different range. However, here is full schematic for this project, how to connect everything. It's very easy to build it, but code is a little tricky. Everything is here. I will provide links for everything below in description, so enjoy with this project, build it if you need it, like and subscribe, and thank you for watching. Bye bye.